Hello, everyone.
All right. Hey, guys. Hi. Thank you for being here today. We're exactly half a mark at reInvent. Along with the step count, I think you're also getting lots of coffee. Hope you're doing good. Thanks for showing up to the session. But before we kickstart the session, though, my name is Sai Chiranteja Gopalani. I'm a senior specialist solutions architect. My domain area is containers. I've been with AWS for about 9.5 years now. And I do everything containers, ECS, EKS. And with me, I have Leandro.
Yeah, I'm Leandro Damascena. I'm senior solutions architect, and I'm doing everything on Lambda. So today we play a role of like the operation guy and the developer guy. One that loves container, the other that loves serverless.
Yeah, I guess so. So in that lines though, so let's talk this, right? So if I were to say you have to deploy every workload that you're going to deploy on AWS for the next 5 years in just one compute service, which one it would be? Show of hands. Lambda? Yeah, okay. ECS? Okay, I see more. EKS?
Whoa.
Oh.
EKS won't.
ECS wins, I guess. Okay, so that's the conundrum that we were going to address with this session actually. So within an organization, we often have as a platform, if I was going to role play as a platform engineer, a developer would ask me for different kinds of platforms that suit different use cases, whether it be Lambda, whether it be ECS or EKS in container world. So how we can devise an app that can be deployed across various services is what we're going to talk through. As a part of this, this slide deck is going to be short. We're going to jump into the coding very soon. The slide deck, this is going to be the agenda for today. We're going to touch what are some modern architecture requirements, then how you can evolve your software architecture patterns to suit that, and eventually we're going to go into the deployment options that are available, and thereafter it's going to be live coding, and let's hope demo gods and everything will work. With that said, okay, when we talk about modern architectures, right, let's take e-commerce app as example, like Amazon. You would have these front ends, which is UI, then orders, catalogs, checkouts. Depending upon the functionality of these apps, like we were discussing as a prologue, will have different compute that may be better suited for the purpose-built requirement. And it doesn't stop there. After you deploy the application, you then go into external services, whether it be services that run on your on-premises, elsewhere, or additional AWS services like the persistence layer that we talk about. And at a scale, managing this becomes a big challenge. Yes, you can have GitOps workflow, you can have these commits that are coming in, and there could be manifests that are refactored across different compute options, but at a scale, it becomes challenging when you have multiple architectures involved in an organization. And that brings us to the need to have your software evolve along with your platform patterns that you devise within your company. First thing is the traditional one, which is monolith architecture. This is going to be the most fundamental unified code base where you have your domain entities, business logic, everything packaged together. Then we evolve into our first level of evolution where it is microservice architecture, where the layers are separated, whether it be presentation layer, data layer, and there will be a clear hierarchical structure here between these layers. And at the end, we could have this clean architecture where the actual domain entity, which is the core business logic, is the center of the application, and there will be several use cases around it, like the ports and adapter model, where you can evolve the application into different use cases while keeping this core business logic the same, and the constructs around it change depends upon the platform you're deploying it to. In today's code talk, most of our discussion will center around the clean architecture pattern. And when you have these kind of patterns, whether it be the monolith, microservice, or clean architecture on AWS, especially for the context of this talk, we are touching both serverless and container solutions, which is Lambda and ECS EKS. And they provide us with various options to deploy these. You can have a container built and be deployed on Lambda, as well as ECS and EKS. Or you could have your application package as a zip package, and that could be deployed on Lambda as well. With multiple launches that came in as a part of this reInvent and the last reInvent, EKS is going to provide you a compute option such as auto mode to automate your data plane infrastructure. ECS has come up with ECS managed instances, which provides you similar behavior. And Lambda, just a couple of days ago, which is his favorite project, has come up with Lambda managed instances that supports a similar functionality.
I hope you liked it.
I think that's a good segue. We're going to stop here on the fundamentals that we're going to touch today, and over to you.
Yeah, thanks a lot, Sai. Before we start, you can switch to my computer.
Yeah. Okay. Got it.
So before we start, how many of yours had to really move application across different platforms? I mean, between Lambda and ECS, between EKS and ECS. Sorry, sometimes I use this paper because I'm an old guy. So, and what challenge that did you face when you're moving application between across platform, different platforms? Someone want to have like a good story or a bad story to talk about this? Yeah, based on our experience in AWS, we see that customers start usually with Lambda because Lambda is serverless, Lambda is easy to scale, and to be honest, Lambda is amazing. But depends on the requirements, depends on the business requirements. Sometimes your company say, oh no, you need to move to ECS, or you need now to move to EKS because my platform teams or whatever. I mean, any requirements or any decisions that your company must have. And then when it happens, you feel that he write at least half of your application. Because now you are depends on the case. Of course, I can see many of you, I imagine many of you are using clean architecture, hexagonal, or ports and adapters, whatever name you can call this. Some of you is probably already using that, and it's like, it's not suffering a lot. But if not, what can happen? So now we start like doing some code. Today we are going through this code and just to aligning, sorry?
Yeah, just to touch on some of the points Leander was suggesting, right? So you start with Lambda, being it easy, but then you run into challenge of execution timeouts, the memory that it can support, resources that it can take, and then you would figure out that, hey, now I might want to move to container services, and then you would go into something like ECS, and that may be a fit for you for certain workloads. Then you would want some open source flexibility, and you might want to go into EKS. So those were the challenges often we see in works, like especially during the migration phases, POC phases, where a lot of our customers were like, which one's the right fit for me? Because even in containers world, there are about 17 ways to deploy containers on AWS. So which one's the right one is a $1 million question. So
exactly, that's a good point. Thanks, Sai. So this is what we're going through today. I expect to cover this topic in the next 20-25 minutes maximum, because you have also deployment and need to show this working. But let's start with like identifying couple between business model, business logic, and infrastructure. Let's start with the monolith. This is like a very traditional monolith application here. It's using fast APIs, so you have a server, you have like an app that implements some routes, and then you have your model or your logic to save your users. But in this case here, you see that save users is not doing only the purpose that was supposed to be. That validate if your user is valid. Saving the user. This is doing a lot of other things. So someone want to point like some critical points here in this monolith architecture? So if not, so it makes some assumptions of your infrastructure that you are using. It's saying that you must use DynamoDB. And it makes assumption that you must use the AWS SDK. And also you must use this name of the table, users table will be users. So this is not doing what's supposed to do. That like implement the logic to save the user. This is make assumption, and it brings with a cost. So let's count like how many problems we can have here. First of all, we have like a mix between logic and between infra, and you have like hard-coded database. And if it's for some requirements, you need to move to a different database tomorrow. You probably need to rewrite all this code here. You probably need to He writes not only users, but also you have orders. And also you can have like, I don't know, shipping, you can have email, you can have any other services that you are running here. So, and also this is propagating like environment variables everywhere. So of course you can say, no, Leandro, I can create a help functions to help you with that. But also you are probably not doing the best stuff to solve this problem. Let's see how this application is running here. So, sorry. Oh, I hope I saved my session. Okay. I have this script here, save users. This is working. This is the magic here. Can you see my screen? It's good? You see that I made I invoked to this endpoint here, users, and you see this is saving the user. It's simple. If you want to start very simple, go there and start with monolith and save your users. But now we start add some new requirements. You see that in this application here, users, we need to save this in a DynamoDB table. But across different environments, for example, if you have like a EKS or ECS, you are probably not saving the table name in the environment variable for any reasons, but you are saving this in a SSM, for example. So let's start like a simple code here, how to improve this one. Here I will import Boto3. I will create a new session here for Boto3, SSM, and now I can make like some new assumptions here. For example, runtime. I can get the runtime here. It can be ECS, EKS, or Lambda. So I will set the default to Lambda, and then I'll start testing this. If runtime Lambda, sorry. Oh, sorry. Sometimes my keyboard doesn't work. So I will get this from the environment variable. If runtime ECS, I want to get this from my SSM, because like some requirements you can have there, and then SSM client.get parameter bar / users / table. If I'm not wrong, this is the syntax, right? To get this. And if this is a EKS, you can have a different way to get this one. You can have this. You can get the name, for example, for a file. I don't know. Let's just pretend we are doing some decisions here based on your application, and then table name equal file.read. So we implemented this new flexibility. So this is good. Sorry. My bad. This is good because we have now flexibility, depends on the environment, but that's true that you need to do that across all the services that you have in this monolith. So if you have like 10 entity or like 12 or whatever, you need to do that everywhere. Again, you can have like a help functions to do that, but that's not the point here. The point that you're trying to make here, how can I have like a clean architecture, a good code that I can, regardless the environment that I'm going, regardless the code that I'm writing, I make it easy to switch between environment. And also this introduces another stuff, because here we are literally hard coding the way that you get the environment variable. How can I test this? How can I inject, for example, a Boto3 client here? I need it to mock. And sometimes my test will be more complex than my code, because now you need to mock everything. You need to create like a lot of tests, or you need to run local tests with Moto or any other library to fake a DynamoDB client. And if you could inject, for example, a DynamoDB client here, or any other instance of client that you want to do that. So this is the monolith. So I mean, that works. This is work. So this is work, and like you saw that I could save the users. I can do the same with orders, but we need to evolve that. We need to make this more flexible. We need to make this, how can I say, better? And I'm pretty sure that some of you are thinking about like, okay, Leandro, I think microservices can solve this, right? I think microservices can solve this problem here. Microservices can solve part of this problem. Because if you implement a purely microservice architecture, you are still not saving the problem to transport this, to deploy this across different compute environments. You are still probably have like some coupled components in your monolith, and I'm not in your microservice. And I'm not saying that you can't combine a clean architecture with microservice. Of course, you can. You can combine, and I see like a lot of customers doing that. But the point of this talk is, how can you make easy to transport and go different architectures? So let's take a look a little bit in the microservices, the way that you wrote this. We still have like some things that very coupled here. If you look at the models, we have like doing like some initial validation. If you look at the controller, we have like the repository here that user repository. We are implementing an in-memory user repository, but also if you need to refactor this, because you are going from Lambda to ECS, this is also not solving the critical problem that you want to solve here. That how can I make easy to go to different architecture? And then that's where going. I'm just showing the microservice here for the proposal of showing the microservice. Someone has any question here? Or something that you want to add to this talk? No? Some of you are using microservices or clean architecture in your workloads? And you combine both? Okay, nice. And it's solving your problem like deploying different architectures or not?
Most of the deployment are in AWS.
Okay.
So it's multiple microservices.
Nice. But your code is ready, for example, to go to another platform? In the sense, probably your code is ready to go, for example, to ECS or to Lambda, to deploy in Lambda or ECS?
I think so, yeah.
Okay, nice, and that's good. So let's go and jump a little bit in the clean architecture. Probably a lot of you are familiar with this architecture here. This is not new to anyone. But here we basically have like three different components here. We have like the application, that's your pure business logic. Probably sometimes I'm writing Python. This is literally your Python code here. You don't need to import any, sorry, let me close here. You don't need to import any dependency here. This application here, this code here, should not be aware what is the underlying database. So because it's like, it's your business logic. And you have here, sorry, I was like the domain, sorry, here is the domain that I'll talk about. Sorry, I opened the wrong folder. The only thing that this code is aware is, I have a user, I don't care where I save the user, but I need to validate. The user must have at least 2 characters, and the user must have a valid email in this format here. You see here that you are not coupling this one with SDK or Boto3 or whatever it is. We are just doing the pure business logic that will help us to move to different architectures. We have the application folder here that uses porters and adapters, like some, I agree that some people disagree with clean architecture and porter is an adapter, but I see like a lot of, in my personal opinion, I see a lot of overlaps between those architectures. And also you can combine both. You can combine and have benefit of both. And the core of those architectures is, how can I solve the problem of having my application, my business logic, and my underlying dependence isolated? But of course, you can combine and you can have benefit for both. So, and here we have the porters. The porters is basically a contract. This is a promise, where I say, I have a user. To create a user, I expect an object type user. To find a user, I expect an ID that is a string. And to delete, for example, I expected another ID. If you see here, this is not making any assumption about the database this is saving. This is only taking care about the logic. This is only taking care about the contract that everyone that wants to save a user, doesn't matter if he's in a PostgreSQL, doesn't matter if it's like in a DynamoDB, they must respect this contract here. And then just let me get my paper here to see if I solve this problem. Oh, but before that, let me come back here and check this. So we went through the monolith, and you have this one. So the second part, the second part here is the application is the port is here. Sorry, I explained that, and we have like our use cases. Our use cases are literally. Let me open here. Repositories. Oh, sorry. Sorry, the use case here. I have here my use case that is. I have my contract that I define where a use is. I have my ports for that. And this use case is, whatever you implement the create user use case class, I will go to expect a user repository, and I will expect it to execute method. And in this point here, you see a new pattern here. In the line 11, you see that you are doing not only expecting a dependence, but you are doing the inverse dependence. Because now when you go to your tests, for example, you can easily mock this one. You can easily mock what a user repository. Because when you're doing unit tests or functional tests, for example, you are not necessarily concerned if this will save on your database. This is more for end-to-end test. This is more for integrated test. But when you think about unit tests, you think about someone that's consuming my API or someone that's implementing my method, they are respecting the contract. That's the general idea here. And then it's make it easy to write some unit tests. So just let me go through here. We understand like what a port is. We understand what's the use case here. We also went through the domain here to understand what's the operation that you expect to do when saving a user. Someone has any question here or anything that want to ask about this architecture? No? Okay, but let's now, you remember that in the monolith architecture, we had to deal with a challenge that we now needed to select the table name based on the environment. And how can you do that in a clean architecture without going through every single service and implementing the same logic? How can I do that in a more clean way? First of all, let's create, just take a look here, the script that I'm following. Let's first create a new file that you call config port. This will be our port to our contract. So everyone that needed to get a environment variable to decide the name of the table, you must respect this contract. So I agree that someone that is doing Python probably by using protocol instead the basic class, but let's do that. So I could call that config port. Let's see the name here. I'll implement this as an abstract class, and I will define two methods here. That means everyone that needed to get an environment variable to decide the name of the table, you must respect this contract. So I'll define this as abstract method. I'll have a method get here that expects self and the key of the table. It could be a str. And then I will just pass, because this is like literally an interface that I don't want to implement nothing. And then let me implement also the get table name, the key, also the entity, sorry, that's the name of the table here that you save. Str. I will explain later what I put here when I complete this implementation. So first of all, I defined the contract that you needed to respect. So everyone that needed to get from an environment variable to decide the table, we must respect this contract. But we need now create our adapters, because at least for me, one of the benefits of like clean architecture reports and adapter is to make this flexible. So how can I make this flexible based on the environment that I defined? And how can I make this flexible enough to add new environments if I want? So let's create here, just let me press here. Let's create our first adapter for that. Create a new folder, adapters, and I will call this new file here, Lambda config adapter. .py. So first of all, I needed to import my, just let me import OS, from application, ports, import config port. So I will define a class here, Lambda config adapter, that implemented this config port. That means I needed to respect that contract. I needed to implement those methods to get my environment variables, and now I implemented the two methods that it is required by this class. That is get, that I have the key RCR. I needed to implement the same interface, otherwise Python will complain about that. And since this is Lambda, I literally want to get my environment variable from my table name from environment variable, and I also needed to implement the get table name. So sorry, it should not complete. Sorry, Kiro, don't do that. So env key, because this is the name of the key. It's like, let's see. Oh, sorry, I need to annotate this one with str. It's like entity, that's the same. And then I will return get env, the env key. So I implemented my first adapter here. And after implement another one for ECS and another one for EKS, for example, we will implement that. We will modify the application to factor this. Regardless of the environment, the application will be able to load the default configuration. So let me create another adapter here that is for ECS1. So ECS config adapter .py. For the sake of the speed, I will copy the same code of the Lambda ECS config adapter. But you remember that from when using ECS, I don't want to get my environment variables from my table name from the environment variables. I want to get this from the SSM. So I import Boto3. I create the SSM client. And now I just need to change this one here. So SSM client.get parameters. And then I get the key, also here. And also here. So, sorry. So you see that different from the monolith, we are not hard encoded this in the logic of save users. We are start abstracting this. We have like adapters. So we have the Lambda adapter. We have the ECS adapter. And now we start like make some decoupling application. I could do the EKS here, but for the sake, sorry, it's parameter. For the sake of the time that you have to demonstrate also the deployment. So let's move directly to how can I factor this in the application? And let me show to you the application here. How can I make this flexible to deploy either in Lambda, ECS, or EKS? This is a basic fast API. I mean, those that are writing code in Python, they are familiar with this code here. So this is a basic fast API application. Nothing different, nothing like super magic here, a basic application. But now we need to think. Lambda expect a handler. ECS and EKS are like the normal containers that you have that just expect an entry point. And how can I make this application aware of environment and easy to deploy in different environments? So if I go to Lambda here, you see that I didn't install Mango, sorry. If you see here, I literally inherit from the create fast API. So I'm preparing my API to be deployed in Lambda. And for those that are coding Python, they probably you know what Mongo is, a proxy in the middle that transform any fast API or Flask API into a Lambda handler. But you see that I only have one API, I only have one app here. I don't have like an app that uses specific code for Lambda or another app that uses specific code for ECS. This is like only one code. This is like the benefit and, from my opinion, the beauty of like a clean architecture. I'm not saying that I'm not using monolith. I have like some application using monolith, either in Lambda or ECS and container. This is what it is. Like the world, we are here because the world started with monolith. So I'm not complaining about that. I'm not saying this is not good or not. But now we needed to, now we needed that we make it our ports, we make our adapters, but now can you make the changes that application will be aware of all the changes that you are making. So for that, let me copy this one here because you're probably running out of time. So let me, and you can go through this file. So for the first time here, let me remove the EKS here, sorry, for the sake of the time. So the first time we are adding the factory file here. That means, sorry, runtime, it's not runtime. Oops. We are adding a file that, okay, when you're creating the application, this application that I'm showing here, before creating this application, you need to make a factory to get the configuration. So I just keep the example here. You need to make a factory to be aware of the environment. So I have now different parts of my code here super clear. I have my ports, that my contracts. I have my adapters that depends on the environment. We'll do different actions. We get from environment variable, we get from DynamoDB, and I have my application. So it's time to make this happen in my application. So different from the monolith architecture, where I make the decision here and I make like a lot of code here, take care about the architecture. I just need to import now my factory here, my factory class here. So from infrastructure dot factory import, what's the name of the class? Create app dependency. You see here? So I create my dependency here, and now when I go into my application here, sorry. Yeah, it's my application here, my Fast API application here. Before I create, oops, I'm sorry, I did a mistake here. So before I created, after I create my app, I can literally do that. So factory, sorry, what's the name of the class? Create app dependency. So now this variable will contain the return of the, it's right. Will contain the return of the create app dependency. That's a factory that's using our adapters. Look like complex? Or not? Someone has one question or not? That's okay? Probably some of you are familiar with that, right? Okay, so that's why I like, okay, go. Can you, Sai, can you get a mic, please? No, there is a hand mic. There is a hand mic. Sorry, man, it's better. Oh, the mic's here? It's on?
Yeah.
Okay. It's off or it's on? Try to.
Check.
Okay.
This is great, thank you. I learned about clean architecture today when I came to your session, but the pattern I'm noticing here is, while it's great, we're sort of separating everything and making it agnostic of the runtime and the infrastructure. In terms of coding, the monolith versus where we are now, we had to add like tons of lines of more code and just replace like 5 or 6 lines of code. So what's your take on that?
Yeah, that's a good point. Every decision that you make, we come with some bonus and downsides. That's true. To keep a monolith architecture, you have like probably problems to scale, because now you need to scale at once, and then you need to go at once. But when it's coming to code, at least for me, maintain a monolith architecture, every decision that you make, I feel that I needed to rewrite a lot of that application, a lot of code in that application. So again, we are not trying to say don't use monolith, use only clean architecture, but every decision that you make comes with downsides and benefits for that. So when you maintain a monolith application, again, I feel that every single change that I need to make, if I needed to make a change to, for example, to not saving DynamoDB anymore, but saving PostgreSQL, for example, it's to create a lot of refactoring. I needed to refactor a lot of stuff. While in this architecture, of course, this is a case where you're getting from environment variable, but it should be like DynamoDB and PostgreSQL. I will show some database here, some files here. But my take on that is, depending on how much you need to refactor this application, you have benefits and downsides to do with monolith and clean architecture. And again, this is hard to say, like, go to clean architecture or go to monolith, because I don't know your use case completely. But for sure, if you want to start a simple application, go to monolith, create a single file, deploy that, especially in Python, that you can create a startup with just one file. That makes sense?
For much larger applications, I think this would probably be easier. You're right. For
exactly.
Applications,
exactly, especially if you are building to an enterprise-grade application that will be maintained not only for you, but maintained for a team that can collaborate in different parts of the application, probably makes sense. But I agree with you. You add like at least, I don't know, 50 files on that.
Yeah, Leandro, I'll probably show the demo. Yeah, so to
okay, so
to carry that particular topic, right? So
yeah, so just let a
pretty much. Yeah, I'll take that question. So pretty much applies to infrastructure as well, based on your team size, design choices, and your knowledge curve. Like whether it be orchestrators that we're going to look or the code, it varies. There's no one size fits all. But what we are showing for the purpose of this code talk is that if you have an architecture like this, it's easy to port across different compute options.
Yeah. And the last change that you need to do is.
You want to take that question?
Okay, sorry. Go.
Sorry. Yeah.
So yeah, we are here in a demonstration. Of course, we have the same code, but now in the side machine, and we will deploy that to different computers.
One sec. What did you do? What happened to the GSH here?
Sorry?
This is your laptop.
It's mine?
I'm not getting the terminal.
I didn't close anything.
Okay, this is what happens. But it's okay. Yeah, we're gonna get it right. Yeah.
Probably need to set a new. Click a new terminal.
It's not working.
What's going on? Okay.
All right.
Sorry.
I think it's the internet. Yeah. Oh. Okay. Here you can see I have in this deployment folder I have both ECS, EKS, Lambda, 3 folders that are here that constitute different architectures that we're talking about. Each one have these shell scripts that we made for this demonstration purposes that deploys the infrastructure. And some of you have used EKS here before. As you know, EKS takes a few minutes for the control plane to be up. So ahead of this presentation, we have just created the control plane 40 minutes ago. So we're just going to go to deployment part for the EKS portions. And this code will be available for you to take home. After this presentation, we're going to share you the QR code in the end as well. With that said, okay, so first and foremost, here I have this build and push shell script, which is essentially building the container image. I'm not going to show the ECR login part here, but as you can see here, it's going to take the Docker file that's in the root location, which is essentially this one, that's copying the base clean architecture code that Leandro just coded here into the root and essentially running it as at the entry point. When I execute this particular shell script, it's going to create an ECR repository, and within the ECR repository, it's going to build a multi-architecture image that suits either AMD or AMD 64 or x86 architectures for Graviton or Intel-based architectures. And now that we have the image that is ready, this single image, single app, this can be used to deploy on ECS as well as EKS. So that's what we're going to show here on the EKS world first. To start with, on the EKS world, we have this deployment script that essentially creates a deployment manifest here. It looks for the EKS cluster being alive, which I'm going to show you really. But once that is done, it essentially goes and creates this deployment manifest. And in this deployment manifest, we are referring to the same image that we just built. And we're going to say, we're going to have Python and buffered one to just have standard out logs, live tail. And then we create a Kubernetes service that essentially exposes it via load balancer so that we can test this application in live. It's going to look in the kube existing config file. It sees that there is an EKS auto mode cluster that is available with 2 nodes. As you can see here, it has been created a couple of hours ago, 116 minutes, its age. And on this, we are deploying the clean architecture app that we just built. And once it is ready, we can go into the EKS cluster here to see whether the infrastructure is coming up. On my EKS cluster here, if I go to the resources tab, I can see that the pods are getting created and they are leveraging compute that is provided by EKS auto mode. Right now there's a node that just came up. So once this node is there, so it's going to use that node to create, it's going to use those nodes to host the pods. And once the pods are ready, we can see that there are 2 of them that transition to running status. Since we created the Kubernetes service as well, service would be creating a load balancer behind the scenes. And if you go to the load balancer console, here we can see that this particular NLB is in provisioning status. It usually takes about a couple of minutes for this NLB to become active. And under the target group, we can verify that the targets are registered. Because we are creating the service based on the label selectors that the deployment has. And it is currently initial under registration process because the load balance itself is in provisioning state. And within a couple of minutes, we should be able to see the load balancer become healthy. And once the load balancer becomes healthy, it'll provide us with the application that we have seen earlier. It will provide us a couple of APIs, users API for this e-commerce app that we are discussing to have our users inputted, and then we have orders API for those users with a custom ID. The same logic that he was showing you in the code, that user ID should be there before an order is processed. We follow the same logic here on this application, and when you hit the API, it will ask you for those as inputs to show your application.
Yeah, and now it's saving the DynamoDB as well. But if you want to make change, for example, to saving PostgreSQL, for example, you just need to change the adapter for that.
Yeah, our load balancer is about ready now.
Users. Move HTTPS.
No, that's not the issue. It's just take time for registration to complete.
Okay.
You see, only one became healthy.
Yeah, but I think you access HTTPS, no?
No.
You need to explicitly put HTTP.
That's all good. And right now, the fast API, we just use the Magnum to create, expose the fast API in Lambda as a handler. But in EKS, ECS, we're just creating the plain HTML file.
Yeah, and in the deployment file, you could make a decision, for example, that the order services are going to be deployed in Lambda, because I don't know, because scaling is different or some requirement, and you can make, like, for example, or users going to be deployed in EKS.
Right. And let's say example, some user ID, and let's say Sai is the username, and that's not my email, don't worry. And let's say that's the email, and we have the user that added, the user ID is random as generated per the code that was created by Leandro earlier, and only with this user ID identifier, we will now be able to, the backend system will be able to process the orders. So if we go to the orders, we should have it ready. Internet.
Probably says K on new pod.
Yeah. No, it's not a pod issue, it's the net. So in your local laptops, when you deploy, it shouldn't take this long, as long as you're not on reInvent network. So right now, this is happening. I have demos as well that I can show you, which I pre-recorded, hoping that this would happen.
Yeah.
And now that we have this, I'll just, while this is loading, I'll skip, in the interest of the time, to Lambda and show you how we have refactored the same to suit Lambda as well. Okay, in Lambda world, we have this deploy Lambda with ALB shell script. Essentially, as the name says, we're going to build this container image out of this code, and we're going to deploy it within Lambda and expose it with application load balancer so that we can hit just like how we're hitting now on the web browser for the verification purposes. Otherwise, you could also use a private Lambda function, like deploy it within the VPC and use AWS IAM auth to have your SIG-v4 authentication as well to access the Lambda. And in this case, one small change that happens is, since there is a Lambda handler, like what Leandro was showing you earlier, unlike container platforms, ECS or EKS, you cannot use entry point. Since Lambda is execution based, it's one-off execution. You need handler, and you need a special Docker file that essentially copies the handler into the task root and leverages the Lambda Python base image where the function would be running. So the first thing that we would do is do this deployment, and the step it would do is essentially it would look at that Lambda image. If it is not there, it is going to create that image out of the Docker file that I just showed you. It will take a couple of minutes. It's about 100 MB image, and once the image is ready, it then goes ahead and creates the Lambda execution role responsible for, required for Lambda to function. And once the role is available, it will then deploy it into the Lambda function, like you see here, create new function. As you can see here, it's the same variables that we have seen in EKS world for tailing the logs. And it's on the x86 architecture that we are deploying, and the function would be in creating state. Once the function is active, it will then look for the networking configuration to create a load balancer with which you can front that and access this function. Now this part is not necessary. We have done it to ensure you will be able to see it like in action. This part is not necessary. It's just that once you have Lambda function deployed, you can access it from within your private IDs that have direct connection as well.
So let's go to takeaways.
With that, give me 1 sec. It's almost getting ready. Okay, so here we have this orders page that we loaded earlier, finally load up. And once you have this order ID, user ID, you can then have an order like echo 1, and it would show up as this particular user requires, like they ordered this Amazon Echo to the backend inventory system. And this is all on EKS. Now, as we have seen, while this is loading up, this page is loading up, we have deployed Lambda function here. That essentially 1 minute ago that we have deployed this function and fronted with the application load balancer. If we go to the application load balancer again, it should be in provisioning state, and it should have the registration happening to the target group.
You can also have the same load balancer with different target groups.
Correct.
Yeah, just did that for the demonstration purpose.
Yeah, and here you have this same exact Lambda function that is being registered. And as your versions change, all it happens is a new registration if you have a different version of your function that is deployed. And once it is healthy, in a couple of minutes, we should be able to see that the same exact application would now be running on Lambda in the same functionality. Application load balancers do take lesser time than network load balancers to do a DNS propagation. Like after it becomes active, it should be much quicker than a traditional network load balancer.
Yeah, for sure we are not deploying ECS because like you just have some few minutes.
Yes, that's okay.
And then you are moving to the key takeaways from this.
Yeah, we have one container platform and one serverless platform that we were able to demonstrate. But the code I said is takeaway for you to try it out at home. And if you find issues or you want to provide any feedback, feel free to create a GitHub issue. And it's maintained by us both, so we can take a look at it.
Yeah, this code will be available in the GitHub if you want to take a look.
And this one's the same. It's going to take a while because of this internet. Okay, so
same code, same application in 2 different platforms.
Exactly same thing. That same behavior that you were seeing earlier. Like you could see here, this is this Kubernetes application. This is its Lambda application. Both are the same exact application running in different compute options because we have the adapter architecture that Leandro showed. I think that's a good segue for the last takeaway slide. I think so that sort of sums up with the takeaways. Like the first and foremost pillar of basically transforming this application to suit different architectures is separating your business logic from that of infrastructure logic, which is going towards the clean architecture approach. And once you have concerns separated, then it is more of configuration driven deployment, like using the runtime that Leandro was showing, like EKS, ECS, Lambda. You can have it the same exact application function in different places. Then there is implementation, which is during the infrastructure phase. As an infrastructure platform team, they can still adhere to their IAC configurations that they are doing. And during the runtime, when you're actually deploying, based on the environment variables passed, the application will choose the platform where it is heading towards. And the payoff would be portability out of it once you have these steps implemented. Yep. I think with that said, this software architecture evolution gives you the flexibility from the operational standpoint is the message that we want to drive with this session. Hope, despite some hiccups, thank you for bearing with it. Hope it was good for you guys. And this is the QR code where you can get this application.
Thanks a lot.
If you want to try it out. Thank you.